Hi guys, Sajjad Hussain again with a new video. In this video, I am going to discuss the design of a 12-story concrete building in a different location. Before, I designed this for a different location, and that was designed as a seismic category A structure. If I can show you, the seismic category A structure was designed based on the parameters given in the book. This was the plan, elevation, loads, live load, superimposed dead load, and the seismic parameters were given as SS is equals to 0.065 G and S1 was 0.024 G. Site class was T. Based on these parameters, this building was categorized as a seismic category A structure. Here, that this is for seismic category A structure, and a simple formula was used, that is only 1% of the total weight is used as a base shear. And we checked and found that the STAAD defines the base shear same as defined by this book. That means STAAD was good to define the base shear, and since in seismic category A there is no special consideration, so it was fine to design a seismic category A building by STAAD. Then the same building is proposed to be in seismic category C area. Now, in seismic category C area, the location is considered to be New York, and the seismic parameters are SS is equals to 0.424, S1 is 0.94, site class was D. Wind load is again changed. Basic wind load is now 110, before it was 145, and they have changed some of the dimensions also. Slab is the same, 8-inch. Beams, before in that example it was 24 by 24, but now these are 22 by 22 inch. Interior column 26 by 26, and exterior column or the columns on the edge are 24 by 24. Wall thickness is the same, 12 inch. So what I did, first I tried to prepare a calculation sheet so that it will be very easy to present to the audience that how the loads are defined, and once the load will be defined, then I will use those loads and I will modify the model in STAAD, and I will run the STAAD model, and then I will try to interpret the results of STAAD. So in this exercise, what I did, I prepared a calculation report first. Here is the calculation report, you can see. Just for the sake of completeness, I copied the same thing, same geometry, and its design criteria. Of course, these are the standards used, and whatever the wind conditions were given, I just copied the wind conditions over here. That means the wind velocity is 110 miles per hour or 49.174 meter per second. Exposure category is B. Occupancy category 2. Importance factor is 1. KZT is 1, and I calculated these values. Similarly, earthquake data is compiled over here. Site class D, importance factor is 1, SS is 0.24 and S1 is 0.094. Then based on ASC 7, I checked the value of FA and FV. FA is 1.6 and FV is 2.4. The load calculation, I started with the roof, and the roof, the load is 10 kip per square, 10 pound per square feet, and there was a point load I considered, which is for penthouse. For 200 kip I divided on 8 nodes, and for each node there was a load of 25 kip. Dead load for the other 4 floors were 30 pound per square foot. Live load on the roof was 20 pound per square foot, and live load on the floor was 50 pound per square foot. Then I tried to define wind load. First I check whether a simple wind load procedure can be applied or no. So the simplified procedure cannot be applied because the height of the building is more than 60 feet. This is not true. So the first procedure, or which is the simplified procedure, cannot be applied. So what I have to do, I have to go to the second procedure. So we have to follow ASC 705 paragraph 6.2. No unusual geometric irregularities are there. So I started my calculation, like wind speed 110 mile per hour, which is equal to 49.174 meter per second. Occupancy category 2, importance factor is 1. Then in my report I included, for the quick reference, the table given in ASC 7 or IBC, and I highlighted as the building is a category 2 building, and the importance factor for wind and seismic is 1. Then based on ASC 7, I checked the parameters like G, CP and CPI for windward, leeward, sidewall and roof. And based on all these values, I prepared the force, net force on the building. So what I did, I took the heights for every floor, calculated the kz value based on the formula, and the velocity pressure, net pressure, and here is the net force. So you can see that if I add the windward wall and leeward wall values, like this 32.57 and 9.28, this comes out to be something around 41-42 kip, and I checked these values. When we add these two, then the net result is the same as it is compiled in the calculation in the book of the calculation. So that means up to here the wind load calculated by STAAD is in line with the documented values. That was fine. Similarly, I did in east-west direction. So both the directions are covered over here, and I checked the values are in well agreement with the values calculated by the book. For the roof load, what I did, I took these values, and the most conservative value, I took this value and applied the roof pressure on the building. Because this is a concrete structure, so this roof pressure is not going to play a significant role, but anyway, for the sake of completeness, I did it. Then I started calculating the seismic load. A simple formula. SS value is given as 0.424, value of S1 is given as 0.094. So based on this and the site class is D. So based on ASC table, 11.4.1, ASC 705. The value of FA is 1.60 and value of FV is 1.24. So I reproduce these tables over here for quick reference, and then I calculate it as per the formula. SMS, SM1, SDS, SD1, and the basic time periods as defined by the book. Then I checked whether there is some irregularities. Of course, the building is not irregular, it's a regular building. And vertical irregularities, there is no vertical irregularities. Fine. Any prohibition, of course there is no prohibition. And check for applicability of lateral force. Yes, we can apply the lateral force, there is no problem at all. And the long period considered was 4 seconds. Based on this, I calculated the value of CU, the time period as calculated in the book, and the time period is calculated as per the book. So almost it's a reproduction of the same thing. And then I calculated the spectral value as per the formula, as per ASC 705. This is the value for this is the function for spectral values, and all spectral acceleration was calculated and a graph was plotted. So when we define the ASC 7 seismic parameters, we will get this sort of responsive spectra, and it will be followed. So although it was not part of the calculation, but I did it for the sake of completeness. Occupancy category is, of course, importance factor is 1 based on the table in ASC 705. This is for the occupancy category. 1 or 2, it should be 1. Then based on these values, I have to check whether this building falls under seismic category C or not. So I checked based on the SSD values and SD1 values, it falls under seismic category C. So then it is established that this building is assigned a seismic category C. Now this is not the end of the story. Once the seismic category C is defined, then we have to look into a table given in chapter 12, and as per the table 12.2-1 part E-8, the response modification factor is given, over strength factor is given, and deflection amplification factor is given. So I just took those values from the table and reproduce over here. In north and south direction, value of R is 5.5. In east and west direction, value of R is 5 only. Omega 2.5. Here in east and west direction, omega is 3. CD for both the cases is 4.5. No irregularities, and the redundancy factor as per para 12.3.4 is 1. So equivalent static is permitted for seismic category C structure. Because at this stage we have to be very careful. As per the table, we have to check whether we can do this equivalent static analysis, or we have to go for another type of analysis like responsive spectrum analysis or a detailed time history analysis. So for this is static equivalent static analysis is permitted. That's why I am using this equivalent static analysis. And based on that, the value of CS is calculated, and for north-south direction the value of CS calculated as 0.032, and of course for east-west direction can be calculated, but then I stopped myself at this stage and I revert back to the model. And in this model, what changes I made? First, the properties, like this wall thickness is 12, wall thickness 12 inch, no change. Plate thickness 8 inch, that is the slab thickness, no change. These are the beams 22 by 22, I revised. These are the columns on the periphery. These columns are 24 by 24, I changed. And for the inner columns the dimensions are 26 by 26. So I modified the properties over here. Then what I did, I modified the wind load generator, and last time what I created and then I modified is the parameters now. For example, the first type windward in X direction, I checked the intensity, it was calculated before. Then the speed, the wind speed was 145, then I revised this to 110. So for all these cases, all these types, that means type 1, type 2, type 3, type 4, type 5 and type 6, the speed, wind speed was updated. Then I modified the seismic parameters over here. I included the accidental load because this is in seismic category C. SS value is 0.424, S1 is 0.094, the longer time period is 4, importance factor 1, response factor in X is 5, in Z it is 5.5, site class is 4, FV and FA and FV is given over there, and then the time period also. At this stage I will try to highlight one thing. If you can see, I am not providing the value of CT and X, so that STAAD will not calculate the time period, it will use these time periods which are defined by me. So if user has defined time period, then it calculates the correct value of CS. I'll show you how. After doing all, what I did, I analyze. Just wait for a couple of minutes, maybe maximum, to get the result. STAAD is still running. Just wait. Because now I changed this perform analysis command to P delta analysis. Now this P delta analysis is taking some more time, because in concrete design, especially when there are lateral forces and of course higher lateral forces are there, then P delta effect is a very significant effect and we cannot ignore that one. That's why this time I changed the perform analysis command to a P delta analysis with 3 iterations. So it's doing 3 iterations, that's why it's taking a little bit longer time. So please bear with me. Yeah, it's okay now. Still STAAD is running. I think it's almost going to finish it. Yeah, done. Thanks God. It took almost 123 seconds. Let us see the output. Let us see the value of CS computed. If you can see along x-axis, the value of CS computed is 0.024 and along Z 0.032, and I showed before that the value calculated for Z direction or north-south direction was 0.032, and in the book the value calculated in east-west direction or the x direction is 0.24. So up to this point it is in total agreement. So I am not going into the design phase, rather first let us see the deflections. Let us go to post-processing mode. Okay. Let's see what else was required here. As you know that when you are designing for seismic category C structures, then you have to consider the vertical effect also. So as per section 12.4.2.2 ASC 705, you have to consider the vertical effect, and the vertical load comes out to be this much, which should be used in the definition of the load, and I could not see anywhere that by default this vertical component will be added. Similarly, the redundancy factor rho as per the code, this is 1. So all these factors has to be checked. Vertical distribution is already done. Dynamic amplification we have to check. We have to check the deflection, what we have to do and how it is done in the calculation. So let's go and see what was done in the calculation. Same thing is done over here. In north-south direction, the value of CS is 0.032, which is correct, and this is the distribution of the vertical force. In east-west direction, the value of CS is 0.024, which is correct. STAAD calculated the correct CS value. Then the deflection. Let us see the deflections. You can see the deflection in north-south direction. At 12th story, the deflection is 1.38 inch. Then it is multiplied by omega, which is 4.5, and then this is the difference between this value and this value, which is the story drift. So this deflection 1.38, let us check whether we get this deflection at 12th story in north-south direction. North-south direction means in this direction, right? And let's see that largest deflection in the direction of Z is 1.577, This is at node number 104. Okay, let's see where the node number 104 is lying. It's YZ node number 104. So here this is the node number 104, and the maximum displacement in Z direction is 1.577, whereas here it is 1.38. Well, it's a little lower, we can say that okay, we can live with that, and then this is okay. Now let us check in east-west direction. In east-west direction means this is the east-west direction. Here the maximum deflection will be along x-axis. So maximum deflection along x-axis is this at node number 409, which is 2.238 inch. But here the deflection is 5.21 inch. That's the big difference. And here where I started losing my confidence in STAAD. This is the point where what I feel that although STAAD asks for fractured properties of the beams and columns, but when it calculates the deflection it does not use it. So it's not very reliable for concrete structures. I will not recommend to use STAAD for concrete structures if the building is lying in seismic category C, D, and C and D. E and F is out of question, forget that one. But up to seismic category A, low-rise building, you can use STAAD. But for high-rise buildings, high-rise means medium-rise size building, maybe 10-12 story building like this one, what I feel that STAAD is not a proper software for concrete structures. I'll check for the steel structure, and then what I felt is in steel STAAD is good, but in concrete no, there are so many limitations. Better not to use STAAD for concrete structure, look for something else. Maybe in my future lectures I will try to use SAP or ETAP and with the same problem, and then I will check whether they are giving the correct values or not. Hopefully you will be satisfied, or you will agree with me. I shall be waiting for your comments, and please do not forget to like and subscribe my channel. Thank you very much. Bye.